Hey guys, here's your video on parts of a wave. Alright, so as you can see I have a wave drawn out here and a bunch of stuff labeled on it, and we're just going to learn what a bunch of measurements about a wave are. Okay, so to start off, a wave is wavy, and that waviness has two parts. It has a crest and a trough. Alright. So the crest is the top of the wave, and the trough is basically the bottom of the wave. Crest you could be more familiar with, but trough is kind of like what pigs eat out of, and you can see it kind of looks like a place that could hold some food or something like that, so that's what they call it, a trough. And those repeat one after another, okay? One wave is considered to be a crest and a trough together. Alright, so that's what one wave is, a crest and a trough. Through the middle of the wave, this dotted line is, if you could think of this as, it's called the line of equilibrium, If you think of it as a water wave, the line of equilibrium is basically the water level before a wave went through it. So it's where your medium would be at if there was no wave in it. Alright, it's halfway between the crest and the trough, height-wise. Alright, two more measurements about a wave. First one is amplitude. Amplitude, abbreviated capital A, because acceleration is lowercase a. It's the height of the wave. Alright, there's two ways to measure amplitude. It's from the line of equilibrium to the top of the crest, or the line of equilibrium to the bottom of the trough. Alright, and those two ways are listed right there. Alright, amplitude, it tells you, I'm going to add this, the amount of energy in the wave. You might have heard of an amplifier. What an amplifier does is it takes electrical energy out of the wall, adds it to, a wave, maybe on a guitar string or coming out of a radio. And what it does is it takes that sound, adds energy, and makes the amplitude higher. Makes it louder, right? That's what an amplifier does. It increases the amplitude, makes sound waves louder. Alright. The next measurement we're going to look at is wavelength. And it has an abbreviation you probably haven't seen before. Alright. That abbreviation is this upside down Y looking thing. It's called lambda. It's a Greek letter. The wavelength is the length of a single wave. That means the length of a crest and a trough together. Alright. You can see we label it on our diagram. There's a trough, there's a crest. The length of those together is one wave. And that is the wavelength, is however long that one wave is. Alright. How to measure wavelength. There's actually three ways to measure wavelength. First is easy. It's the crest and the trough together. How long your crest is, that's half a wave. How long your trough is, that's another half a wave. Those two lengths together get you the wavelength. But, if I were to take away half of the trough and kind of add it on this side, if I were to take away the first half of the trough here and start my wavelength measurement at the bottom of the trough, then I would have to add that half a trough on this side, back to the middle of the trough right here. And that's another valid way to measure wavelength. That's called trough to trough. Alright, so if you go from the bottom of one trough to the bottom of the other, it's another valid way to measure wavelength. It gets you the same number as crest and trough. Alright, and because trough to trough works, obviously, crest to crest is going to work just as well. Alright, they're basically the same thing. Alright, so three good ways to measure wavelength: a crest and a trough together, trough to trough, or crest to crest. This is another valid way to measure wavelength: top of crest to top of crest. Alright. Now here's an example problem where I'm going to ask you, what is the wavelength in this diagram? I drew many waves here, and I said the length of this picture is 12 meters. Alright, and I'm asking you, what is the wavelength? That's the question. Alright. So what I usually do to start out figuring this out, I'm like wavelength. Well, I want to know how long one wave is. That's what I'm asking. If I'm asking for wavelength, how long is one wave? All of these waves are 12 meters long, but how long is one of them? How long is what is one wave? It's a crest and a trough. Alright, how long is one of those together? Alright, so let's just count, crest and trough. Alright, so that's one wave, two waves, three waves, four waves. So 4 waves are 12 meters long is what the diagram is saying. Alright, so how long is one of those waves? Well, if 4 waves are 12 meters long, then I guess 2 of those would be 6 meters long. And one of those would just be 3 meters long. Like that would be 3 meters. That would be 3 meters. Now I'm at 6, half of 12, right? Another 3 meters. Now I'm at 9. And another 3 meters. Would get me 12 meters, right? So if the whole picture there is 12 meters long, I'm just looking for how long one wave is, and that is 3 meters, right?